we're gonna find the measure of one exterior angle on each regular polygon, and we're gonna round the answer to the nearest tenth if necessary. Okay, so yesterday we talked about the interior angles, the angles on the inside. Okay, so now exterior, I'm talking about the angles on the outside. What I mean with that is if I was to extend each of my sides, I'm talking about these angles. That's what I mean with exterior angles. Now, I'm gonna count how many sides did my polygon have. In this case, I have 5 sides, right? I'm not gonna waste your time, but we could tell there's 5 sides. Now, the angles on the outside, it doesn't matter how many we have, they always add up to 360. The angles on the inside does vary. The angles on the outside always equal to 360. So I'm asking how much is one of them? Okay. I know all of them is 360. I know there's 5 of them. So what I'm going to do, let me go 360 divided by 5. Like I said, the angles on the outside always add up to 360. The interesting part is if you were to look at these corners and put them together, it will create a circle. So that's why we said, well, 360 then, because it creates a circle. There's 5 of them. And I know they're all measured the same thing because we said this is a regular polygon. So I'm gonna go 360 divided by 5. That means that each of them is gonna be 72 degrees. Cool. Let's take a look at question number 8. Let me count how many sides there are. See, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. There's 11 sides. So for me to figure out how much is one of the angles on the outside, I'm gonna go 360 divided by 11. According to my calculator, I get 32.72, 72, bunch of 72s. But I know I have to round my answer to the nearest tenth. Okay, tenth sounds like a 10, which is a 1 with 1 0. So 1 decimal place. I do take a look at the second decimal place, which is too small. Remember, 4 less is too small, so I'm just going to ignore this. And my answer will be 32.7. So the angles on the outside always add up to 360. You're like, Sir Leonzo, which angle? Can you show me one of the exterior angles? Yeah. Choose a side, make it bigger, in that angle. That's what we're looking at. Okay. Let's take a look at question number 9 here. Solve for x. Okay. It seems like I have this angle, this angle, this angle. I have all the angles on the outside. So I'm just going to say, let me add them all. And they're going to equal to 360. Okay. And I know when I'm going to add them all, first of all, I'm going to combine like terms. So 7x plus 5x plus 4x plus 4x plus 9x. Let me add my x's first. And that gives me 29x. Then let me combine those that don't have an x. So I see a positive 4 plus 9 minus 6 plus 1. And that happens to give me 12. And I know all of this is equal to 360 because the angles on the outside always add up to 360. Cool. The rest is pretty simple. My plus 2, because I want to have the 29x by itself, the plus 12. Let me move it over as a minus 12. Don't forget to switch the sign. So I have the 29x equals, now 360 minus 12, I know is 348. So I'm going to say this is equal to 348. Let me draw this longer so I don't get confused. Now to get the x by itself, let me divide both sides by 29. I'm gonna get that x is equal to 12. Good. The instructions say solve for x, so I'm done. Let's take a look at question number 10 here. Okay, so what I'm gonna do, I'm gonna add them all because it seems like I have all my angles are my exterior angles. So let me add them all equals 360. And I know to add them all first, let me combine like terms. So 5x plus 5x plus 4x plus 2x plus 6x plus 4x plus 5x, right? I'm just combining my x's. I'm just combining my like terms. So I have 31x. Then let me combine the non-x. So positive 5 minus 6 plus 3 minus 12 minus 5 plus 3. So 5 minus 6 plus 3 minus 12 minus 5 plus 3. I get negative 12. 31x minus 12 is equal to 360. Okay, I want the 31x by itself. So this minus 12, let me move it over as a plus 12. Don't forget to switch the sign. So I have that 31x is equal to 372. Now to get the x by itself, let me divide each side by 31. X is equal to 12. Oh, 12 again. There you go.